Hi, this is Michael Baldwin from the AAA Cope project. Today on this podcast, I'm with Angelica Mendoza Beltran from our partner 20 LCA Consultants to find out more about their work on life cycle assessment and that they're contributing to in our project. Hi, Angelica. Thanks for coming in today. So first, the main question, what is life cycle assessment, LCA, and why is it important?
Hi, Michael. Thanks for having me. Let's jump into matters. What is LCA and why is it important? Well, LCA stands for Life Cycle Assessment, and it is a systematic analysis of the potential environmental impacts of a product throughout its life cycle, including the production of raw materials, its manufacturing, its transportation, use, and maintenance, waste processing. So if there is any waste generated in the life cycle, processing that waste is also part of it. And in the end, also if there is any recycling of materials. I could give you an example. For instance, imagine a coffee cup, and then pretty much any raw material you need to make the cup. So we can imagine some mud, maybe, and then manufacturing this cup. So any energy that you might use to cook this mud. So that would also be part of the life cycle of this cup. Then if you have to transport it, retail it, also all material and energy you're using to clean it up while you're using it, that will all be part of the life cycle of this cup. And then in the end, in the disposal, if it actually breaks and you end up putting it in your waste bin, or if you actually just recycle it somehow, I wouldn't know exactly how, but think if you would do anything with this cup in the end of life, that would also be part of its life cycle. So LCA is pretty much trying to cover all that, all the impacts happening in all these phases of the product. It actually goes back to the 1960s and 70s, when it first was commissioned by very big companies, but only until the 1990s it was standardized and formalized, in particular by the International Organization for Standardization, ISO. So we got this ISO standard, which actually tells us how to perform an LCA for products and pretty much any system that you can think of. Nowadays, as you can think, it is becoming very important to protect the environment. So any robust tools that can help us understand the environmental impact of manufacturing and consuming products, it's more relevant than ever. So LCA is one big important tool, part of this field, and actually it's gaining more and more relevance in time.
Okay, yeah. So your company, 20 LCA, they are specialists in this field of work. How did the company come about, and what is it actually? What is its actual business model, if you like?
Well,
Actually, the first
2.0
question.
LCA.
Sorry, the first question. I'm going to interrupt you. First question is, why is it called 20 LCA? Because that's quite unusual.
Yes, it is. It's quite a special thing. Actually, I was not aware of this. I had to ask my bosses about it. And it came out that basically the way that you write, like 2.0 dash LCA. So 2.0 dash, it basically means zero, second to none. So we are basically the second to none LCA Consultants, which is kind of a pride name.
Right, yes. Very clever. That's amazing. All right. So what does the company do? How does it operate, and what's the sort of work it actually does?
Well, 2.0 LCA, it's a relatively young company. It started back in 2000, and it was started by Professor Bo Weidemann, who's a professor still at Aalborg University in Denmark. And he's a renowned academic in the field of LCA. And at the time, the company, well, it started as a small consultancy, which was owned by former and current employees. And then basically it aimed to continue the work of several EU projects that resulted in the creation of a database that we still actually use to calculate LCAs. And then so they wanted to continue the work developed under these projects, and then basically the company was created just for maintaining that. But then, of course, the work further expanded into other areas of sustainability, and it consolidated. And we are still using LCA, well, as a base for most of our products and services. Nowadays, well, our main service is to perform LCAs for products and systems. And we have this one-to-one client approach where we sort of handcraft the solution to each client. And yeah, basically all the work we do is pretty much related to LCA.
Okay, so is it the companies will pay 20 LCA to do this analysis for them?
Yes, indeed. So we work with small companies and with larger companies. You can imagine all the range of sizes of companies. Whomever is interested in performing LCAs or also in reviewing their own LCAs, or who's actually maybe developing specific tools that are based on LCA. So we have a set of products and services that we provide, all based on LCA. But actually, we're expanding more and more, not just staying in the realm of environmental LCA, but also moving into social LCA, also more economics assessments, monetarization, a bit more complex assessments, which are still based on LCA, but a little bit beyond.
Okay. So can you explain for us a bit more how an LCA is actually performed? What kind of analysis or calculations are done to make an LCA?
Yes. So, well, in essence, it's, let's say, not rocket science, although it can end up in quite complex models. But in essence, it's actually performing 4 phases that are very structured phases, and each one has its own objective. So in the first one, what you actually do is to set your goal and scope. And that actually means that you basically sit together with whomever is commissioning the LCA and whomever is actually doing the LCA. So they sit together and have a chat about what is this modeling exercise about, right? So it can be about comparing 2 products. So do we want to know what is the difference between 2 products that perform the same function? Or it can also just be about analyzing just one product. So in my example, the coffee cup, we just want to know what is, let's say, the most impactful substance in the life cycle of the coffee cup. Or you could also say, well, I actually want to know how I perform compared to my competitor. So that can also be a goal. And then you sort of set also the scope. You say, well, what are the geographies I'm looking at? Is my product produced in many places? How does it relate to, for instance, to time? No, is it produced like annually, or are we talking about something that takes much more time to be produced? So all these aspects about how much detail to put into the LCA as well. They go in the definition of the goal and scope. Then you go into the second phase, which is the inventory phase. And then here, what you do is collect data. So you have basically defined the goal, you know the scope. So you start to collect data for each of the activities included in the life cycle of whatever you are looking at. This is usually a phase that involves a lot of research. You have to talk also again with many different people in the supply chain, normally of companies, who are the people that know how things actually come to be. You know, how are they made, what things are needed, what emissions are produced. These kind of questions are answered in this phase. Then the third phase is actually the impact assessment. It's called life cycle impact assessment. And in this phase, what we do is we generate the aggregated impacts for the product throughout the life cycle based on the data that you collected in the inventory. So you can imagine that, for instance, in the coffee cup example, you collect how much energy it is used in each of the phases, but then you have to aggregate it throughout the life cycle. And to produce one indicator of energy, well, you do that in the impact assessment. It's just aggregation and sort of compilation of all the impacts in a specific families of impacts. So imagine a very easy example could be greenhouse gases. You aggregate them into the climate change impact, and it will tell you basically the carbon footprint of a product.
All right.
That's the life cycle impact assessment phase. And then finally, the interpretation phase, which is the fourth one. You basically look at all your results and you interpret them in the light of your goal and scope. So you kind of reflect back on your results. You can start doing more sophisticated analysis like sensitivity analysis, where you change parameters of your model, try to see, oh, what if I change this? How much does that affect my results, my conclusions? And then sort of interpret your results. And that's it. That's basically an LCA. And you get information about the environmental performance of your product.
Right. And once the customer, the company has the LCA, what will they do with that in terms of their strategy or what to do about a product?
Well, there's many things that you can actually do with an LCA. First of all, one thing that is very common is to identify the environmental hotspots, which are like activities and substances that generate the most impact on your product in the life cycle, and you can actually tackle those in the case that is basically in your domain. But if it's out of your domain, then you at least know how to manage your suppliers, so it actually can also help in supply management. Another thing that you can do is optimize resources and reduce waste. So because you have managed to collect all this information about your product, you learn a lot about how much resources you're using and how much waste you're generating. You get a lot of indicators. So it kind of gives you KPIs to just work towards certain targets, right? You can also do sustainable product design. So you actually look at new technologies, emerging technologies, and then try to benchmark them against more, let's say, conventional technologies, obviously with the aim of trying to improve the designs. That's another application. And then finally, there is a lot of regulatory compliance and risk management that you can also do with this.
Yes. Okay. Yeah. So, in terms of your own job, how did you get into working in the field of LCA, and what do you like about it?
Well, I actually got to know about LCA when I did my master's degree. That was my first interaction with life cycle assessment. I did a master in a field called industrial ecology. And there, I basically learned about sustainability and tools that you can use to assess sustainability. And LCA was part of that. So this is kind of how I basically learned about it. Then further, I expanded my knowledge on LCA while developing my PhD. So this was a real deep dive into the topic of LCA. I looked into various aspects of uncertainty in LCA, how to manage uncertainty in LCA, because as you can imagine, lots of this data that we collect and use and sort of try to model, we end up modeling pretty much the whole economy of the world, and that's very uncertain. So there is a lot of uncertainty in there, and managing that is important. So that was my PhD, and this is where I actually learned a lot about LCA. And then I continue working with LCA along my professional career. So during my postdoc, I also work on LCA tools more from a circular economy perspective, but still based on LCA. And more recently in the consultancy job, of course, it is the base of what I do nowadays, interaction with companies, with many stakeholders, actually. And yeah, I just love about it that it is a very versatile tool. Well, of course, it has its limits. It doesn't assess everything, but it covers many aspects of environmental sustainability, among which you have resource use, waste, ecosystems impact. There's a lot of relevant things in there. And then, of course, I also like the fact that you have this life cycle thinking in it. And the fact that it basically it is a great tool. You know, it's just very versatile, and you can play a lot with it. Let's put it that way.
Yeah. So in the AAA project, 20 LCA is performing LCA lifecycle assessment. So what are the particular considerations you're dealing with in AAA code?
Yes. So in AAA code, our product of interest are coatings. This is actually quite new to me as well as a product. So I have actually learned that coatings are products that are used to treat surfaces in environments where they are highly touched or exposed to microbes, for example, buses or hospitals. And therefore they can spread disease more easily, these surfaces. So these coatings are sort of made to avoid this spreading of diseases. So in AAA, partners are developing coatings, but in this case, we are trying to make them based or inspired in nature. So the technologies that we're using are sort of, let's say, quite innovative compared to what is already out there, no?
Yeah.
And then the essence of the coatings from AAA code is the nanocellulose. So nanocellulose is the core substance. So a large focus of the project and of the LCA work, of course, will be on this nanocellulose production.
Yeah.
So because nanocellulose is biodegradable and it's a renewable material, we expect it will perform better in many impact categories compared to typical alternatives like the silver nanoparticles-based coatings. And then so we will have to focus a lot on the impacts of producing the coatings, compare them with these typical alternatives. And so far, we are very much focused on collecting the relevant data from partners who are producing the specific compounds that basically make up the coatings that we will develop. And then we expect that the production of the nanocellulose will definitely be a hotspot for several impacts. But also, I'm expecting that because we are using many chemicals in the production, maybe other compounds will also need a bit of treatment, no, and sort of focus within the project.
The active compounds.
So yeah, we're very keen in obtaining first results by the end of the summer of this year, hopefully.
Great, yeah. So looking ahead, what's kind of new in LCA? Where is it going in the future, do you think?
Well, LCA is evolving a lot. Actually, it's been changing a lot since, of course, the 60s, the 70s, and 90s. And nowadays, we are no exception, and in the developments of science field. And then we expect that AI is actually going to play a very significant role in the way that we are performing LCAs. Probably many of the procedures that we do, the way we collect data, all of that is going to be affected by AI. So I expect that our job is going to look very different in the future. I mean, moreover, we're also in the middle of several planetary crises. So, I mean, we expect that LCA will continue to become even more relevant and even more important in the regulatory and monitoring processes of companies, of governments, is actually going to become more and more relevant. I also expect that LCA will involve more and more sophisticated techniques. So initially, LCAs, let's say, were very simple because, of course, the data available and the machines we had to calculate the LCAs were relatively simple. But nowadays, everything is so sophisticated that you can really, the amounts of data that you can process are unbelievable. So we are obviously also benefiting from this. So that will definitely happen. And then in the future, more than ever, it will be important to keep an eye on the robust practice of LCA, as there is always a risk of greenwashing and malpractice.
Right.
So
Yeah.
it is very important to keep an eye on how things are calculated.
Okay. All right. Well, thank you very much, Angelica, for your time today. We've learned a lot about LCA and how it's helping us to be more sustainable in the future with new products and services. So really look forward to seeing the results of your work in AAA Code later in the year. So thanks again for your time today and all the best.
Thank you very much for having me, Michael.